Welcome to the Cloud Pod, where the forecast is always cloudy. We talk weekly about all things AWS, GCP, and Azure. We are your hosts,
Justin,
Jonathan,
Ryan,
and Peter.
Episode 220, recorded for July 19th, 2023. The Cloud Pod reads Llama, Red Pajama. Good evening, guys. How's it going?
It's good, Justin. How are you?
Yeah.
Good.
It's sunny and hot.
Yeah, hot is an understatement here on the West Coast. I don't know about New Jersey where Matt's at, but here in California, it's like 100 degrees in LA where I'm stuck. And I imagine it's similar temperatures where you're at, Ryan and Jonathan.
Mm-hmm. Yeah, I saw a map yesterday of high temperatures across the country, and it was like 80s, 90s, 100s, and then San Francisco's right there, 64 degrees.
Always San Francisco's like that.
Yeah, but global warming is a hoax, right? That's what they keep saying.
I'll trade you just straight hot for the humidity we've had here recently. I'm from Florida. I think it's been humid here.
Oh, that's a hard pass. I will not make that trade.
Yeah, like I like the good weather, but I definitely don't think I could do Florida with the humidity. So I'll take my dry heat and I'll take the 105 degree temperatures every day of the week.
Hang on, you didn't mention that you were from Florida in your application to the Cloud Pod.
Yeah.
Wait a second.
We may have to revisit some things.
Wait, Jonathan, you also came from Florida at one point. I mean, you didn't start there, but you definitely came from there at one point.
I did.
Was that your first hop in the U.S., though?
No.
Oh, right.
Yeah.
All blurs together.
As a kid, I spent a little time in Florida, too. So I think this might all just come unraveling really quick.
I mean, your problem, Ryan, is that you not only spent time in Florida, but also New Mexico.
Yeah.
So it's the combination of the double whammy of those two that's your problem. But
yeah. And like my entire family is like from those two places. So
it's all good. We all have family issues. All right. Well, let's move into cloud news. So detecting and stopping recursive loops in AWS Lambda functions is now available for you. If you have a Lambda function that's going to exceed 16 invocations and appear to be a recursive loop, Amazon will automatically stop that and notify you in the CloudWatch alarm or in the AWS Health dashboard. This supports integrations with Lambda functions that talk to SQS, SNS, or directly via the Invoke API. And this can help reduce costs if you accidentally ever created a recursive loop that ran for many, many days and cost you many hundreds of thousands of dollars, which I think there was a person on Google not that long ago who did something similar, and Google trotted him out on an apology tour, basically get them to refund him his money, that he had to basically give a cautionary tale. So I do appreciate that Amazon is giving you this option. Now, of course, if you had done this before, Amazon would have probably not charged you as a nice thing to do for you. And now they're like, well, if you turned off this feature, then it's on your own. You can turn it off if you have a recursive loop that should be more than 16 times, which they do point you out to a guide about reading about all the things you should know about recursion before you do this. And if you really want to turn it off, you can then reach out to customer support. And they will tell you that's a terrible idea. You shouldn't do this. And then they'll turn it off for you.
That's funny because that would totally break my my Lambda backup tool that I wrote, because it was literally one tool that spawned dozens of other jobs to do different things. And so, yeah, that would, that's not going to work anymore.
I mean, again, like they say 16 invocations and it has to appear to be running a recursive loop. So I had to assume it's more than just a counter. It has to have some brains that if you're running Lambda with different inputs, even though it's it's a sequencing situation, that it wouldn't detect that as a recursion. But I'd have to go read the guide probably.
I can say I've definitely caused in the hundreds of dollars bill very rapidly by this in the past in a dev account. So it's definitely something that's easy to do if you are doing recursion and you make an if statement the wrong way.
Indeed. Everyone's done it once.
Or just something that generates events. Yep. Yeah, exactly. Yeah. I've done it for sure.
No, I didn't. I overdid it on the error handling, and I just keep taking out my dead letter queue and I'm putting it right back into the queue.
Mm-hmm.
Yeah, I've done that. Mm-hmm. Well, if you are a Fargate user and you've been jealous of all those people using ECS who've been able to use the Seekable OCI or SOCI capability of lazy loading of containers, you now have this feature available to you. Those of you who don't remember what this is, there basically was some research done that basically said that image downloads account for 76% of container startup times, but on average, only 6.4% of the container data is needed to actually start the container to start and do useful work. With this now coming to Fargate, you can now use it for both Fargate ECS as well as Fargate naturally and ECS compute. All you have to do is basically build a SOCI index for the container image, and you can do that with the open source tool Sochi Snapshotter, which will have an automatic method to do it. We'll just scan your code and repo and package and basically create an index, or you can manually create those index points if you know what you're doing, which if this is the first time you've heard of it, you don't know what you're doing. So don't do that.
I still haven't tried this. I should have by now, but I'm too lazy. But it is, I like the idea. I hope it is click button in a sense of for generating, the index to make it easy. I don't know. I like the idea.
I mean, basically what I saw in the documentation was it's literally a CLI tool, and you basically create the container, and then you do this Sochi CLI, basically hook off of it, so it starts the container up and it maps what it's doing, and then basically saves that index for you. And then you just push it up to one of the Amazon container registries. So it looks pretty straightforward. The devil's always details, though.
Mm-hmm.
I feel like I've definitely looked at this, and most of my stuff is all back-end automation scripts. And if they take an extra half a second or second to run to boot up, it doesn't hurt me that much.
It's only at a huge scale, right? Like Amazon's noticing that 76% of that container is container startup time, but individual apps.
Well, and I suspect this is a big issue if you're doing like data learning sets and containers, right? So you need to load up a large amount of data set into the container to basically then be able to train the model. But you can start training the model on a subset of the data. You don't need the full thing to be loaded. And so I suspect that that's really where the use case for this comes into play, is in big data training and AI training.
Be also useful for people who don't really optimize their containers and they have a bunch of things there that they never use, because potentially those things never get loaded into Fargate at that point.
Yeah, I mean, I've seen some pretty bad public images now from like a couple of different open source companies, and I'm like, why do you have like 30 layers in your container base? Like, you can squash these down. So yeah, it's true.
I was going to say, I wonder if it actually helps with Windows containers too, because there's so much extra in there.
I think when this came out originally, it did not. Maybe that has changed, but I'm not sure. I'll have to do some real-time follow-up here and look at the website.
Windows containers are still not supported on Fargate, so
well, that's true.
I guess it doesn't help you.
But you can run this on ECS too, so you don't necessarily need to be on Fargate. Originally, this was not launched for ECS, and I think it's available in EKS now too. But I'd have to do some. Well, for those of you who are using FSX for NetApp, it now supports SnapLock, which is a really great way to make you burn a lot of money, make a paperweight out of a SAN. That's because SnapLock basically enables write once, read many worm functionality. SnapLock volumes prevent the modification or deletion of files within a specified retention period and can be used to meet regulatory requirements and to protect business-critical data from ransomware attacks and other malicious attempts at an alteration or deletion. Apparently, FSX for ONTAP is the only cloud-based file system that supports SnapLock and the ability to move SnapLock data to lower-cost cloud storage for now. But since NetApp's on all the other cloud providers, expect to see it follow shortly.
This is kind of a can of worms, really. I see the advantage of protecting against ransomware, but also customers or consumers have a right to have their data deleted. So what happens if your data is on a worm drive with a policy that says it can't be deleted, but regulatory requirements say that you have to delete customer data?
I mean, S3 is the same feature, so they're going to end up with the same thing with S3 Object Lock, I think is what it's called.
Mm-hmm. Yep.
I mean, a lot of it's around legal retention. So I guess you're thinking of like California law or like GDPR, which requires people to be able to delete their data. So I would think this maybe is more useful for like contractual data and stuff like that.
Yeah, I mean, this gets more into like PCI, credit card transaction logs, or getting into SEC statements that you can't modify. Like once they're written, they need to be basically omnipotent in some ways, where they're not able to be edited or changed because they're records of the financial institution. So this isn't typically something you do for the use case of like user profile data, because that data is deletable. So there's no regulation that would require you to have to keep it. But yeah, I do remember early in my career. I think it was someone bought something related to the EMC Clarion, and it was a worm unit, and something went wrong, and I think they did a recursion loop in their code and wrote a bunch of garbage to the logs, and basically took $600,000 worm array and basically turned it into a piece of junk. And so the EMC had to basically come out and actually do a lot of work to get it back, so they could use it.
No.
Because it was set to indefinite like delete, can't delete indefinitely or some terrible like 1,000-year retention, something ridiculous. Good times. The Amazon Fault Injector now supports ECS and EKS pod workloads. So you can set up all of your chaos experiments for EKS and ECS workloads. I mean, containers are their own chaos on their own part, so I don't know how much chaos you want to add to them. But through this method, you can do task or pod-based CPU stress, IO stress, kill process, network black holing, network latency, and network packet loss, which is pretty good. EKS and ECS, of course, are the two big container platforms on AWS, and supports all of it.
We have our own bugs. We don't need to inject defects. We plenty of our own.
But some of these actually are like really interesting and really useful, like network latency, packet loss. Like even though you're in the cloud, there still is latency, and there still is design for failure. So if a data center does go down, or have issues, you could definitely have latency. And despite how terrible coding Jonathan's and Ryan's can be, it's very difficult to test the latency or packet loss or things along those lines. Just nobody ever look at my code and we're good.
I guess the thing is, if you're running tests from the cloud to the cloud, AWS have a very reliable network. Latency and packet loss isn't something that I've come across in 10 or more years.
Direct connects?
I didn't use direct connects.
I've had direct connects go down on me. So
it's definitely real world scenarios to get there. Right?
If you're building applications like mobile apps and things, then you have the whole rest of the internet and mobile network and all the rest of the network up until the point that you hit your VPC. So being able to simulate latency external to your application, I guess, is the real selling point.
Yeah, I mean, like you're ideally testing your high availability, your fault tolerance, and your auto healing, and so those are things that will happen in the internet. And if you can, test those scenarios to help you make your application more robust, it'd be amazing. I just wish I could do that. Like I have so many other things I'm doing that adding my own stressors is not something I want to add to my development process at the moment.
Yeah, other than the basics of fault injection when it first came out, I don't think I've really used it since because, like you said, I wish I could get to a level where I'm maintaining an application to a level where I'm like, yeah, I'm going to make it really hardened and resilient. Like, no, I'm like barely functional. Moving on.
MVP.
Yeah. But I do like this. I mean, I think these are real world scenarios. It's, I liked the injection where it was just removing components. I do think that these are useful, and I bet you running through these, you're going to find a lot of, weird behavior in your scaling and your container launching that you would have never expected. It's strange. If you've been in enough outages, weird behavior is weird.
100%.
That should have been our show title. Weird behaviors are, the cloud pod says weird behaviors are weird.
Well, in news that I am not shocked about, Honeycode may be on its last legs. Originally launched in 2020, Honeycode was supposed to be the answer to AWS low-code development, which uses a simple drag-and-drop interface to help users easily build apps without advanced software engineering skills. Amazon is apparently currently providing bare minimum support for Honeycode with no active promotions or sales activities for the app, according to people familiar with the matter internally who do not review their name because they are not authorized to touch the media. They basically called it a KTLO project, which joins other services like WorkDocs, WorkMail, and SimpleDB. So it'll last forever, but won't get any love or support. Amazon, of course, has great infrastructure as code solutions over the years, but has always struggled with SaaS apps outside of Connect, which is kind of a unique one, with many products compete with Dropbox, Slack, Tableau, and others with only marginal success. Interesting enough, though, the Honeycode was a very high-profile project and was supposed to be the era of new growth for Amazon, to the point where they actually put it on its own website, separate from the AWS portal, which never made any sense. And it is, but the Honeycode people who are still at Amazon are listed in the directory apparently as being absorbed by the next generation developer experience team that is focused on all of the new generative AI. Which, if you're going to let Honeycode kind of die on the vine, the next version of Honeycode, which hopefully has a better name, would be generative AI based. So it makes some sense that this is, this product was a little too bespoke and too late to market, and now it's time to reinvent this from the ground up with something like AI.
It is kind of fascinating that they didn't just pivot, right? So where build your Honeycode application through natural language, but must be too complex to quickly modify.
I mean, I think if you could divorce yourself from the branding and, functionally going from click, drag, and drop to AI is enough of a pivot that I feel like you should just pick a new brand, because Honeycode was terrible.
Yeah, it was terrible.
Yeah, I wouldn't even say late to market is an appropriate thing. It was literally a reproduction of like Visual Basic from the 1990s. Have you been waiting months and months to hire your new AWS, GCP, or Azure architect, only to have them be poached at the 11th hour by a startup with a juice bar? Initiatives stalled because you're having trouble hiring? Well, I have a simple solution: Foghorn Consulting. Foghorn Consulting provides top-notch cloud engineers to the world's most innovative companies and can be burning down your DevOps and cloud backlogs as soon as next week. Foghorn certified AWS, GCP, and Azure professionals are armed with infrastructure as code, and from day one will be designing performant, optimized cloud-native or hybrid environments that deliver on the promise of cloud. Their FogOps solution even provides on-demand cloud engineering to augment your existing teams. Visit www.foghornconsulting.com or send an email to cloudtalentnow@foghornconsulting.com and tell them the CloudPod sent you. Your dedicated FogOps team is with you for the long haul, and they bring their own juice.
Moving on to GCP. Document AI is introducing powerful new custom document splitter to automate document processing. Apparently, Google's been very focused on documents this year, with the launch of Custom Doc Extractor in February and the Custom Document Classifier in March. And with the ability to now split documents in the Document AI Workbench, you'll be able to help users automatically split and classify multiple documents in a single file. CDS allows customers to sort and classify the documents as needed. And for example, the businesses can validate if they have all the needed documents for an applicant in a single PDF. For example, if you uploaded multiple pay stubs and bank statements and you combine them into a single PDF, that becomes a bit of a challenge for the computer to now validate that you have all your documents if you can't split these documents up. As well as you may need to be able to send those things to one person who does asset inventory or income verification, and other documents might need to go to something like the mortgage insurance company. And so being able to split these documents with AI allows you to then pass them down to downstream processes in a more automated fashion, which is a benefit in many, many workflows as well. The one I'm familiar with, of course, is mortgage, but there's many others.
I was going to say tax people, around tax season, getting all the stuff right now. I know my person, I just uploaded to, or even like TurboTax, you upload it to, you have to select what it is for it to be able to process it. So if you can just say, here's all my files, go figure out what they are and split them accordingly, it'd be nice.
In the pre-show, I was talking about my expense report, having to basically give like the top page that has the account summary, but I don't really want all my like individual cell phone transactions. And so like being able to do stuff like that automatically, pre-processing where you're splitting that up and not storing, ages and ages of this page intentionally left blank in your cloud storage is probably a pretty good idea. I like it.
Put it on your worm drive. It'll last forever.
Forever and ever.
Well, a feature that has been long promised is apparently coming to Azure. For those of you who've done anything with Windows and patching and security, you've always cursed the dreaded reboot. And I believe in Windows Vista or Me or something, they were like, hey, we're going to be able to do less reboots, which never actually happened because those less reboots require you to actually have patches that don't require them. And because Microsoft's a trash fire of security issues, Patch Tuesday always has things that had to require reboots. So you don't ever not reboot them. But if you are using apparently the core version of Windows, you do have that ability, allegedly. I still don't believe it. And apparently now they're bringing that to hot patching for Windows Server Azure Edition VMs with the full desktop experience, not just the core. And apparently this will allow you to get workload impact with fewer reboots, a lower workload impact. Faster deployments of updates as the packages are smaller, install faster, and have easier patch orchestration with Azure Update Manager, and better protection as the hot patch update packages are scoped to Windows security updates that install faster without rebooting. Bull crap.
I mean, I just prefer not to manage pets and just shoot the servers in the head and deal with them from there. But that's just me. I prefer not to ever log into my servers, ever deal with them in any way, shape, or form. If there is a patch, the Windows Auto OS update feature, I don't know what the official name is on Azure for it, but it literally just takes care of it for you in the scale sets. You don't have to deal with it. Works great. Why I need to actually patch local servers? I prefer not to do this.
Says a guy who doesn't run SQL Server. That's a pet.
That is why I pay Microsoft to run it for me.
Exactly. Yes.
Yeah. Well, with improvements like this, like Azure's going to be the only place to host Windows workloads, right? Because it's all the gripes with Windows. You're like, well, why would I run this in another cloud provider? I have to reboot it every 5 minutes.
I mean, you do have the problem that now you have to deal with Azure on a regular basis, and
fair enough,
those issues.
Yeah.
But minor quibbles.
Just 12-hour survey calls. Don't worry about them. They're fun.
Okay. Well, if you had to hot patch your server and it didn't need that reboot, you probably don't need this feature. But if you are going to be rebooting the server and you want to still send traffic to that dead server because you thought it was going to not reboot, you can now turn off health checks in the Azure Traffic Manager and keep sending traffic to your nodes that are no longer available to you to serve that traffic. You can use a third-party health check if you'd like to determine endpoint health, and ATM native health checks can be disabled, allowing a more flexible health check setup, which is just a weird feature. I don't know. Always serve for Azure Traffic Manager. Now, taking your site down every day.
It's an upgrade from the previous iteration of never serve Traffic Manager, and so I guess this is maybe better somehow.
I know I like the feature. I mean, you're gonna make fun of it, but I think it's a pretty decent feature actually. It's just seem weird to remove health checks, but what they're providing is a way to plug in your own health check infrastructure. So if you need something more complex than just a REST call or a web call that gets 200 or 500 back, then you can build something a lot more complex that runs much better tests, and then plug that into the load balancer.
Yeah, but now how do I tie that more complicated health check into scale sets or into other things? Like, it's a lot of heavy lifting for me to now pull this all into APIs, where why don't you just give me the ability to run a custom health check as the health check through serverless, and then based on the output of what I give you, you can then do different scale set operations. Why completely divorce yourself from the responsibility and say, now you have a third party that's responsible, we're off the hook, when you could have given me a system that allows me to run my own code to do health checks?
Well, I mean, they're giving you a system that lets you write your own code to do your own health checks. I mean, the third party could be yourself, I suppose.
Yeah, but again, it's the native hooks that you already get built into Azure's health check infrastructure that you're now doing a lot of toil and heavy lifting for little benefit.
Yeah, I can see though if you have a legacy app and who doesn't have legacy apps that don't have health check endpoints or things like that, you may need to write something significantly more complex to either do like simulations of activities or whatever in order to verify that a node's healthy or not.
But also a health check should be lightweight and quick. I don't want a health check to be logging in, making a transaction, waiting for a response from a transaction, and doing all that. It's putting unnecessary load on your system. And if the response time is too long, then it's not going to respond back in a good, fast way to kill any boxes that aren't.
Hang on, let me get the number of my VP of engineering. Pass the message on.
The only other thing I could think of this is as the old school concept of classic load balancers, ELBs on AWS, which used to fail close, and this, which and application load balancers, which fail open on target groups. Is I wonder if this is just like somebody wants their stuff to fail open, and they don't want the health check, and just route it their way. And we just want to fail open to it and just show customers 500s for some strange reason. That's the only thing I can think of for this. Though I assume AWS did it because they were sick of support cases, but that's just me.
But I guess if you think everything's down, then like the Hail Mary is, well, let's just send it to everything and hope that something replies. You can't get more down. You can't get more down than everything being down. So what's the harm? I guess is the motivation there.
It's just a great way to get your customers to be your health checks. That's all I see here. All right. Well, Microsoft is apparently trying to suck up all of the AI things. They already have a pretty strong relationship with OpenAI, and now they're announcing their partnership with Meta to bring Llama 2 family of LLMs to Azure and Windows. Llama 2 is designed to enable developer and organizations to build generative AI-powered tools and experiences. Meta and Microsoft share a commitment to democratizing AI and its benefits, and we're excited that Meta is taking an open approach with Llama 2 for this article.
That's kind of neat. Give it away for Facebook, Meta, giving it away for free, but I'm sure they're going to get a percentage back of the revenue for monetizing it as a managed service. So that's a pretty good way to fund research.
And then Matthew and Ryan were here last week to talk about Storm 00 or 0558, which was apparently an attack done by a Chinese actor who was able to generate key data to log in as users' AD. Several companies or government agencies' Azure AD accounts, which was a really bad thing. And we talked last week about how they had not really given a lot of detail in their particular article. So they've come back with a very in-depth threat intelligence write-up of this problem, including a set of IOCs you can deploy to potentially detect this behavior in your own environment or in your own email services. And so basically you get a pretty comprehensive understanding of what the issue is, except for the one big question that we had last week is still the big question today, which is what exactly did they steal and how did they get it? So they did clarify that they acquired an inactive MSA or multi-step authentication consumer signing key and used it to forge authentication tokens for the Azure AD Enterprise and MSA consumer to access Outlook Web Access and Outlook.com. All MSA keys active prior to the incident, including the actor-acquired MSA signing key, have now been invalidated, and Azure AD keys were not impacted directly. The method by which the actor acquired the key is a matter of ongoing investigation, though. The key was intended only for MSA accounts, and a validation issue allowed this key to be trusted for signing Azure AD tokens, and this issue has now also been corrected. So they fixed the root, which is good, but they still don't actually know how they acquired the key, or at least they've not publicly announced how the hacker got the key that was used in the whole thing. So this is not great, but I appreciate the thoroughness of this write-up versus the original document. And I do hope they answer the final piece of the puzzle so we all feel maybe a little better or a little worse. I'm not sure how I feel, but I'd like to see this put to bed.
I do like how open they're being about it and how they're actually like posting all the details, probably, as fast as they can about some of these things, and, being very honest. And I hope that many more companies use this as a model going forward of like, don't hide what's going on. I always feel like you're better off sharing. And maybe that's just because you hear these things like LastPass and all these other companies that try to hide pieces of it for a while, and inevitably it all comes out. So it's nice to be able to see people talking about it up front.
I was just going to say it was nice that they published the source IP addresses and things so you could add them to your deny lists, and they sort of fingerprinted some of the activity so that you could easily build it into your own WAFs or security solutions.
But it's a proxy, so it's just an open proxy they went through. So if you're going to block, it's soft ether. So isn't that just like a Tor network public proxy?
Yeah, but it's China, so yeah.
I mean, typically when you get these IOCs, you want to protect yourself from these things, which have been known as compromised, and then you want them to prove they're not compromised before you allow them back in anyway. So it's not uncommon to have these type of lists of IP addresses in an IOC. And then you can either detect it and then action it and research it yourself, or you can just block it at the source if you have no business doing anything with China. So. Okay, well, hopefully they'll answer the last piece of this puzzle, and then we'll all be satisfied enough with the answer. Well, that's it for cloud news this week, guys. Any other news that I missed in this week's roundup?
You assume I can see life past my keyboard these days, which no chance.
No chance.
Yeah, doing this podcast is the only way I learn anything. I'm like, oh, there is an outside world.
Yeah,
it's four of us on a screen
talking about tech stuff. Yeah, it's great.
And one listener, Oren.
Yeah.
Oh, I'm Wayne too. I guess we have two listeners. And my mom. Hi, Mom.
Thanks, Mom.
Yeah. All right, guys. We'll see you next week then here in the cloud.
See you later.
Bye, everybody.
Bye, everyone.
And that is the Week in Cloud. We'd like to thank our sponsor, Foghorn Consulting. Subscribe on iTunes or wherever you get your podcasts and tweet us your feedback at #TheCloudPod. Or join our Slack channel, go to our website, thecloudpod.net for sign-up instructions.